So we're given this square-based pyramid. We want to find the perpendicular height AB of the triangular face of this square-based pyramid. So we're trying to find this length here. Now we can form a right-angled triangle like so. So if we draw that triangle out here, this is A and this is B. If this length is 40, it should be clear that this is 20 centimeters. And we're given that this side is 30 centimeters. So using Pythagoras' theorem, because this is right-angled, AB squared would be equal to 30 squared minus 20 squared, which is equal to 500. So AB is the square root of 500, which is approximately 22.4 centimeters. We now want to find the height of the pyramid. That's AC here. We can form a right-angled triangle here. We can see from the diagram that that is the triangle ABC. So A, C, and B. And we just calculated that this is the square root of 500. We know from this length here that BC would be 20. Now this is a shorter side, but once again, we can use Pythagoras' theorem. So AC squared would be the square root of 500 squared, which is just going to be 500, plus 20 squared. Sorry, take away 20 squared. So that's 500, take away 400, which is 100. And therefore AC is 10 centimeters. Just needed to take a bit of care there. Of course, that had to be a minus because AC is a shorter side. This one was the hypotenuse there. Finally, we want the size of the angle BAC. So we're wanting this angle just here. Now, if we look at that as the reference angle, this side is the opposite. This one is the hypotenuse. So, Toa, opposite and hypotenuse means sine. So the sine of our angle, let's just call it x, is equal to the length of the opposite, which is 20, over the length of the hypotenuse, which is root 500. And therefore x is the inverse sine of 20 over root 500. And we just need to calculate that. So we've got the inverse sine of 20 divided by the square root of 500. And that is 63.4 degrees. Correct to 1 decimal place.